Hi, this video is meant to help you have a kind of overview of how to do the spectrophotometric titration of the cabbage extract. It's not meant to replace the procedure, so you look at the steps carefully, but after you watch the video, it'll probably be a little easier to understand what the steps are saying, so you understand what's coming. Now, the first thing you have to do is to prep a stock solution of the cabbage extract. It's 10 mg per ml. So we can use the whole amount of the cabbage extract that we have. And by using that, we'll get more significant figures by measuring out a big mass. And we're going to make much more solution than we need, but it's an inexpensive chemical, and therefore it's not a problem. So we're going to prepare it directly into the 100 milliliter graduate cylinder. So place the 100 ml graduate cylinder on the scale and turn it on. And if it doesn't read 0, you can tear it and make sure it reads 0. And then open up the cabbage extract and dump the whole thing in there. And take note of the mass there. We're going to use that in our calculation to figure out what volume of water we have to add in order to get the correct concentration. The first thing is just to convert that mass into the number of milligrams with this conversion factor. 0.55 grams is 550 milligrams. Next, we want to calculate what volume of solution we need to prepare with that 550 milligrams in order that the concentration works out to 10 milligrams per ml. So here I'm just going to rearrange and solve for x, the number of milliliters. So I rearrange that equation for x, and I find out I have to make a total of 55 milliliters of solution in here in order to make the concentration that I want. So I got some tap water here, and I have a dropper ready to do it. And I'm going to carefully pour in some water to get close to 55 mLs, maybe until I'm around 50. And then I'm going to use the dropper to top off to get as close to 55 as I can see. Now I want to swirl that or do whatever I have to do in order to get it well mixed. I don't think we gave you anything long enough to reach down and stir. So this is just water and cabbage extract. If you want to put your hand over the top, that wouldn't be all that bad. Okay, so there we have our 10 milligram per ml cabbage extract stock. All right, the next thing we want to do is prep an HCl stock solution that is 1 milligram per ml in the cabbage. So what we're going to do is take this tube that contains the HCl solution, and we're going to open it up and take a small amount of the solution out so that we have exactly 45 mLs in this tube. So you can use a dropper for that and put the HCl solution in a waste container. And use the markings on the container to adjust to exactly 45 mLs. Then take a clean dropper and take 5 mLs of the concentrated cabbage extract and carefully add, using the markings on the container here, up to the 50 ml mark. Okay, and I'll just top it off with a drop there. And this solution now, I have 50 mLs total volume of, and it has a concentration of 1 milligram per ml. We're going to repeat the same thing for the sodium hydroxide. Okay. So if you look at the sodium hydroxide tube, you can see there's about 50 mLs in there. So I'm going to take some out, just like I did for the HCl, to lower the level down to 45 mLs. Okay, I'm going to do that using a clean dropper. And I don't need that solution. I'm going to throw it into the waste. Okay, so I've just taken out about 5 mLs. Now it reads exactly 45 mLs in the marking there. Okay. And now again, I'm going to take some cabbage extract and add until this goes up to the 50 ml mark. Okay, and to the drop, I get as close as I can to the 50 ml mark. And I can cap this. And I want to actually invert both of them to make sure they're mixed well. So put the caps on tightly. Okay, and you can see they have a different color. It's the same amount of cabbage in both of them, but in sodium hydroxide, the solution is purple. In HCl, an acidic solution, it's kind of pink. Both of these have the same concentration of the cabbage extract. So as we combine them, the concentration of cabbage extract won't undergo any dilution. No matter what mixture we make of these two, the combination, no matter what volume of each we have, will be 1 milligram per ml for the cabbage extract. I showed how to prepare some of the solutions in an earlier video. We're going to start using those solutions. But the first thing today is to adjust the position of the flashlight to optimize the values that we'll be getting from the spectrophotometer. So let me turn the camera. All right, so the first thing to take care of is that the spectrophotometer itself needs to be immobilized to get good results today. So I've taken a small piece of double stick tape and I put it on each end here so that my spectrophotometer will not move around during the experiment. In this experiment, you're going to be using a 630 nanometer light filter. We're not going to change filters during the experiment. So I can take that and I'll put it in this position in front of the cuvette holder. Now in this experiment, it's much more important than in the last experiment that you optimize the position of the flashlight to get the most light that you possibly can from the flashlight into the dissector. So to start off with, you could have your flashlight at about the distance where it is now. What you really want to do is turn it on and get a look at the intensity on the screen over here on the app. Now, ideally, we want the image of the light source, the colored spot that's going to be on the screen there. We'd like it to be completely within the square that data is collected within. So if it's not within that square, you need to move the flashlight further back so that the spot of the image of the flashlight is smaller than the square, and then it's approximately centered. The next thing is you should look at the intensity on the screen and see as a good estimate about what it's starting at. We'd like to have values around 200, and we want to make sure that the flashlight has a clear, sharp image. So if you move the flashlight around like this, you'll see the image change. You'd like a nice uniform image across the surface of the screen. So it probably would be best to have it pointing as squarely towards the cuvette holder as possible, but determine the best position by moving it back and forth. Looking at the light intensity I see now, I see a light intensity that's well over 200. It's maxed out at 250 something. So I'm going to take one of these neutral density filters you have in your kit, and I'm going to put it in the light path. Again, I'm going to go back here and I'm going to look at the light intensity I see on the screen of the app. And when I do that, I see a value that's still over 250. So I'm going to put another neutral density filter. Now, if you didn't need one neutral density filter because you had an intensity of around 200, that would be fine. You don't have to put two neutral density filters. You might need 0, you might need 1, or you might need 2. If two neutral density filters doesn't get the intensity down, then you're just going to have to move the flashlight further and further away to get the intensity somewhere between 150 and 200. Now, these filters aren't going to get moved during the experiment. We're not going to change them like we did in that other experiment. So I'm going to use a piece of Lego to hold them in place so they don't get knocked around. Okay, so now this is very secure. The filters don't even move. And the last thing that I have to really about getting secured is the flashlight down here. You should have the flashlight at this point adjusted to an intensity where it's around between 150 and 200. And what we want to do now is to gently try to tape it down without moving it if we can. So you guys have some Scotch tape in your kit. I don't think it has a dispenser. But peel off some Scotch tape and very gently place a strip of Scotch tape across here. Okay. Then take a look over here at your app and see what the light intensity is. If it's changed only a small amount, that's okay. If the flashlight got moved and it changed a lot, then undo the tape and do some trial and error. You want to get the tape, you want to get the flashlight taped down with the intensity being somewhere between 150 and 200 with a nice spot centered in the middle of the data collection square. Once you think you've got it pretty well settled down, that it's in the right position, put more tape. All right, I'm going to do it with Scotch tape. If you have some duct tape, that would do a better job, actually. Maybe we want to send you duct tape next semester. I've got a few strips of tape here now, and this doesn't move around a whole lot. Like I said, if you had some duct tape around or masking tape, you could put more tape on top of it. We'd like it to be very immobilized. Okay. Whenever you turn the flashlight on and off throughout this experiment, and you should do that a lot, you want to put your hand on the body of the flashlight to hold it steady and gently press the on-off button. That way you don't move the flashlight around very much at all, even though the tape should hold it in place. Now the next thing is to create the blank cuvette, and the blank cuvette is a little different than the blank cuvette in the last experiment. The blank cuvette in the case of this experiment is just the HCl cabbage extract solution. So you can put about a dropper full of that in there. It would be a good idea to label it as the blank because we don't get it confused with any other cuvette, and put it here in the path of the light. And we want to record that intensity in the data table right here. That would be I0. I have a value of about 201. For this first trial, the solution that we're using as the blank is also our sample. So you can copy that value right here. For the first trial, we're going to say it has a transmittance relative to everything else of 1. Now, since we're not making a measurement, we should turn off the flashlight. And the next thing we need to do is we need to measure the pH of this solution that we've just used to create the blank. This solution we need to measure out about 22 milliliters of and put it inside of a clean Dixie cup. We're going to run the reaction of the titration in this cup today. So get a clean graduated cylinder and measure out 22 mLs. And I'll top it off carefully with the dropper. Then we can put this solution aside, put this 22 mLs in a clean Dixie cup. Your pH meter has to be calibrated in pH 6.86 buffer in the same way that we did in the ionization constant of acetic acid laboratory. So I have it right now in a pH 6.86 buffer. I'm just going to turn it on. And as soon as I see the screen light up, I'm going to press the calibrate button for 5 seconds. 1, 2, 3, 4, 5, and let it go. And you should see the number is 6.86 for the calibration pH blink, and then it should settle down. It's now been calibrated. I'm going to take it out of that buffer and wash it into a waste container that I'm going to make out of a Dixie cup. Shake it off a little bit and place it into that solution. Whenever we're measuring pHs throughout this experiment, we should let the pH meter settle down for a minute, and we should also do a little bit of stirring. After it appears to settle down, if we stir it, we may see the pH continue to change. So every time we do a pH measurement, we're going to do this. So I'm going to pause the video and give this a minute to equilibrate. Okay, my pH meter has stopped changing with a little bit of stirring. So I see a pH of about 3.42 there on the screen. And we're going to be making a lot of pH measurements. So it'd be a good idea if you have another cup around, like a coffee mug, to stand this Dixie cup up so that you don't have to worry about it getting knocked over easily. So the next thing I'm doing is I'm going to record that pH. Looks like it's about 3.45 right now. That's the lowest pH that we're going to have in our data set. As we perform the titration, we're going to be mixing the sodium hydroxide solution that has the cabbage extract with the acidic HCl solution. And as we do that, the concentration of the cabbage extract will not change because it's the same in both, but the acid and the base will react, and we'll get different resulting pHs. Now, the next thing we want to do is measure the pH and measure the light intensity for the other solution that we prepared, the cabbage extract in the sodium hydroxide. So you can prepare a cuvette for that by adding about 1 dropper full of that solution. And our blank cuvette is still in there. And every time we make a measurement of a light intensity, we're going to also make a fresh measurement of the blank. And we're going to record those. We do that in case the flashlight moves slightly, or if the flashlight's intensity varies because the battery is being drained as the experiment goes on. So the first thing I'm going to do is I'm going to turn my flashlight on gently, and I'm going to read the intensity that I see. It's about 192. It has changed slightly for whatever reason. And then, without touching anything or moving anything else, I'm going to switch solutions. And I see a value of about 90. So I'm going to record those two values. So those two values would go here. 192 was the I0 value at the moment, and the I value was 90 for that solution. I next have to measure the pH of that sodium hydroxide solution. You can take this little bit of the sodium hydroxide solution and pour it back into the main container it came from. And we need to take about 1/2 of a clean Dixie cup full of the sodium hydroxide solution in order to evaluate its pH. The exact volume doesn't matter. I'll take this out of the reaction mixture and wash it off with distilled water. You can shake it off a little bit and put that in the sodium hydroxide solution. If your pH meter is shut off, it's okay to just shut it back on. And I'm going to do all the same things I said before. I'm going to stir this, and I'm going to wait about a minute with the video paused. Okay, looks like my pH meter has settled down. I'm reading a pH of about 9.08. So I need to record that in the data table. And that would go here. That is the pH for the most basic solution that we're going to have in our data set today. Next, you can pour all of this sodium hydroxide containing cabbage solution back into the stock solution. And clean off your pH meter. Okay. And it's okay for a short period of time to just put the pH meter down on the desk. You don't really want it to dry out. You wouldn't leave it for days or hours, but in between trials, it's okay to leave it on the desktop like that. Now, most of the kits, I believe, have pipettes that have markings on them that you could read. But if, in case yours doesn't, a few of the ones that I have don't, then you want to make a marking on your pipette about 3 inches up. Okay, that will be about 2 milliliters of volume. And we want to do a number of trials where we're going to draw up that volume. So if you want to make a marking with your permanent marker about where that will be. Now, over and over again, we're going to follow the steps I'm about to show you, that we're going to take an aliquot, this volume, of the sodium hydroxide containing solution. That's about right. And we're going to add it to the reaction mixture that we're going to be keeping in here. Each time we add it, you can give it a little swirl. It doesn't take a lot to get them to mix and react well. And each time we do this, we want to measure the pH of that solution and then measure I0 and I for that solution. So it doesn't matter which order you do it. Don't get confused about what you've done and not done. I'm going to take my pH meter and put it in here. And as I've done in other cases, I'm going to swirl it around and wait about a minute with the video paused. Okay, my pH meter is settled down. It's reading about 3.69. So I'm going to record that in the data table as the pH for the first edition. That's the first edition that I just did, 3.69. Next, I'll take my pH meter out, and throughout these trials, as you do the titration, you don't have to wash in between each one. Each trial is very similar to the last. Okay. We want to take this out and fill up the other cuvette that you have with just a little sample of that reaction mixture. Okay. Now, gently touch your flashlight, hold it in place and turn it on. Put your blank in. Observe the intensity. My intensity is around 170. Without doing any movement, switch cuvettes to the reaction mixture and observe the intensity. I get about 162. Turn the flashlight off. Record those two values before you forget them. The reaction mixture that I just measured the intensity of goes back into the container I'm doing the reaction in, over and over again, the same pattern. Now again, I'm going to follow that same routine. I'm going to fill up this pipette to about where that blue mark is. I'm going to add it here and swirl it around a little bit. Put my pH meter in there. It's turned off, so I'll just turn it back on. And I'm going to let it settle down for a minute. Okay, it looks like my pH meter is settled down. I see a value of about 3.93. Okay, that's the pH for the second edition. Makes sense, the pHs are increasing as I add the base to the solution. And then I just have to do the same steps. I'm going to take this, I can lay it out on the table for a moment, and shake this cuvette out and pour a little bit of this reaction mixture in there. Okay. And again, I'm going to take care to not disturb my flashlight's position as I turn it on. I will put in the blank, observe an intensity. I see an intensity of about 180 this time. I'm going to switch here. And I see an intensity there of about 168. Okay. So I'll gently turn my flashlight off. and record those two intensities. Don't get confused between your blank cuvette and your cuvette that is used to monitor the reaction mixture. The reaction mixture always gets poured back into this container. Okay. And you're just going to continue to add these aliquots and measure the pH and measure the intensities until you have done a total of 10 additions of the HCl containing cabbage extract into the reaction vessel. Then we're going to switch and we're going to make a reaction vessel that has 22 milliliters of the sodium hydroxide solution, similar to how we started off the first round. Measure out 22 mLs there. I'm going to put that in a clean Dixie cup. And then I'm going to take a clean pipette and I'm going to continue to do these same trials, doing the spectrophotometry and the pH measurements, except I'm going to be adding one dropper with 2 mLs of the HCl-based cabbage extract to the sodium hydroxide. This allows us to get data points that are higher up in the pH scale, that are more basic. And we'll do this for 10 data collections, doing all of the same steps, measuring the pH, doing the spectrophotometry, and then pouring the cuvette back in here and repeating with another aliquot for 10 more trials.